Right, good morning, everyone. Right, people, today I'm just going to give you the scope of the work for the September exam as well as the final exam in November. And then we're going to do grade 12 statistics. Right, people, all I want to emphasize is the achievables in each of the section of work. Right, algebra, that is question 1 in paper 1. Algebra, equations and inequalities is 25 marks, plus minus 3. There, people, there's always a 4 to 5 mark, which is a level 4 question, but the rest of the sums everyone should be able to do. When it comes to patterns and sequences, you will be asked the quadratic number pattern. You either get asked what is the formula of the quadratic number pattern, or you will be asked more insight questions on the quadratic number formula. You will be asked sigma notation, and you will definitely get the sum to infinity. So those are the 3 things that you can focus on. Those are the achievables in sequences and series. Finance, growth and decay, usually that is 15 marks, plus minus 3. Patterns and sequences is 25 marks. Now, when it comes to growth and finance and decay, then you can look at half the marks is grade 11 work, half the marks grade 12 work. Functions and graphs is 35 marks, plus minus 3. And then people, part of the functions will be the inverses. The inverses will be focused on the straight line, the parabola, and the exponential graph, which is the logarithmic graph. Calculus, what are the definites? First principles, rules. You either sketch the cubic graph, or the cubic graph will be sketched, or you can get a derivative graph, and then you can get applications of calculus. And then the probability is 15 marks plus minus 3, and then half the marks will be grade 11 work, and other half will be grade 12 work. So it's around about 7-7 usually. Right. In paper 2, statistics is 20 marks plus minus 3. Analytical geometry is 40 marks plus minus 3. You're going to get the grade 11 analytical geometry, and the grade 12 is the circle. Either the circle with center at the origin or circle with center AB. Trigonometry, people, around about 30 marks is trig. And then it's usually the diagram that's drawn in a specific quadrant, or you've got to draw the diagram in a specific quadrant. You will be asked identities, usually the double angle identity is there. The general solution is there, and that is also usually one with a double angle. And then you're going to get asked the double and the compound angle in and how to manipulate that in specific sums. Trig graphs and trig formula. Now, people, the trig graphs, you either get the shift up and down for the sine, cos, and tan, or you get the shift left or right for the 3 graphs. You must be able to do both. Euclidean trigonometry is 50 marks, and then Euclidean geometry is 40 marks. Now, people, you can get easy marks by knowing your theorems and being able to apply your theorems. Use the fact that if O is the center of the circle, you can apply 5 theorems. Tangent, if you see the word tangent, you can apply 3 theorems. If you see cyclic quad, you can apply 2 to 3 theorems, depending on how they ask it. So those are and your proofs. You must know your 4 grade 11 proofs, and you must know your 2 grade 12 proofs. That's easy marks. 6 to 7 marks is a proof. Bookwork. All right. So people, that is the scope of the work. So I'm sure that if you really put a lot of effort into it, that you will be able to achieve your goal. Right. Let's look at statistics grade 12. People, look at the notes in front of you. I'm going to read the question. A matric class of a certain high school had to vote for the chairperson of the RCL. The scatter plot below shows the IQ of the 10 learners who received the most votes and the number of votes they receive. Now, people, there's a scatter plot, all right, all over the place. Before the election, the popularity of each of the 10 learners was established, and the popularity score out of 100 was assigned to each. The popularity score and the number of votes of the same 10 learners was received, and the most who received the most votes are shown in the table below. Right, now they say calculate the mean of the votes. Now people take note. Popularity score is X. Usually, you will see that if it is written in rows, the first row is in terms of X. Your second row would be in terms of Y. Is that clear? If it's in terms of column, your first column is X. Your second column is Y. So then you can distinguish between the X and the Y axis. What is written on the X axis and what is written on the Y axis. Now, in this case, they ask you to calculate the mean of the votes. So I need to determine the average of the Y values, correct? Okay. Now people, let's quickly understand this. I'm going to tell you what is asked in every paper. They can ask the mean of discrete values. Now, these are discrete values. So how do you find the average or the mean of discrete values? It is the sum of the scores over the number of scores, correct? They can also ask you the mean or the average of group data. And if they ask you that, then you've got to find the midpoint of the interval. And then you've got to find the frequency. So the midpoint times the frequency gives you fx. F times x, the frequency times the midpoint. And then you can use the formula to work out the average of that. Is that clear? So that is in your examples. We've done it in the examples. Go through it. They also will ask you, calculator usage, standard deviation. They're going to ask you the regression line. That is the values of A and B and the correlation coefficient. Now, out of the 20 marks, if you are able to work out the mean of discrete, the mean of group, standard deviation, the values of A and B in the regression line, and the correlation coefficient R, you've got 8 out of 20 marks already, calculator usage. All right, so make sure that the calculator you use on the day is the calculator that you are familiar with, because every calculator, you've got to use different keys to be able to work that out. Is that clear? Okay, so you got 8 marks, just working out that. And you will see, as I work through this, what are they going to ask? Exactly what I told you. Is that clear? Right, let's quickly have a look. Now, in this case, people, they are going to ask you to work out the mean, that is the average of the votes. There's 2 ways in which you can do it. You can also go to the stat mode. Then one is the variance, and you can key it in. I also want you to go ahead and also key it in on your calculator and see if you get the same value. Or you can just find the sum of the scores divided by the number of the scores, and that should give you also the correct answer. So people, there I've used it. Then I say AC shift stat. And then I'm going to 4, which is variance. And to work out the standard deviation, I press 3. And that gives you I've worked out the standard deviation, but let me go back. Right, I'm going to redo it. So let's go to the stat mode. I want you to work it out on your own while I'm working out mine. Right, people, if I press 2, I can work out the average. The average is 15,5. Okay, so you can use your calculator to work out the average, or you could use the sum of the scores divided by the number of scores, and that will also give you 15,5. Is that clear? the sum, if I add 9 and 22 and 10, if I add that row divided by 10 scores, I can get 15,5. Now people, for standard deviation, let's quickly have a look here. For standard deviation, I'm going to go out, I'm just going to say shift stat for variance. Standard deviation is 3, and that can give me 4,59. Now people, you can see that 4,59 is your standard deviation. Is that clear? There it is. Right. What have they asked? Mean. What have they asked? Standard deviation. The learners who received fewer votes than one standard deviation below the mean were not invited to the interview. How many learners were invited? Now, one standard deviation below the mean is, in this case, the average of y minus the standard deviation. We worked out the average is 15,5. The standard deviation was 4,59, and that gives you a value of 10,91. So how many values lie within that range? Now people, 10,91. If you look at all this, there is only 2 values that are below 10,91. So 10 minus the 2 gives you 8 values lie within one standard deviation of the mean. Right, is that clear? Are you with me? Right. People, in 1.3, they ask you to determine the equation of the least squares regression line for the given data in the table. Now, so what we've got to work out is the values of A and B. Now, on your own calculator, you can work it out. I will work it out on my calculator. So in this case, I'm going to go mode, then I'm going to go to stat, and then I use 2, which is a plus bx, and then I'm going to key it in. So here we're going to say, first of all, I'm doing the x, 32, 89, 35, again, 82, 50, 59, 81, 40, 79, and 65. Right, people, then you must go to the top. And then you key in 9, 22, 10, 21, 11, 15, 20, 12, 19, and 16. And then people, once you've got that, you press, right, AC, shift, stat. Now you go to 5, which is reg, and now you can work out A. A is 1, so 1 equals. So this gives you 1,77. So A here, people, you can see A here is equal to 1,77 plus BX. So if you want B, you say AC, shift, stat, reg, which is 5, and you want B, so it's 2 equals. That will give you 0,22. So 0,22 is the value of B, BX. Is that clear? Right. Now they ask you, predict the number of votes that a learner with a popularity score of 72 will receive. Now people, all we need to do is in place of X, I need to replace 72. That gives you a value of 17,61, which is, if you round it off, it is 18 votes. Now people, if you take a value, I'm going to explain this because you need to know this. There's a difference between interpolation and extrapolation. You need to understand the terminology. If you are taking a value, for example, of 72, 72 lies within the range. Do you see that? The smallest here is, in terms of x, the smallest x value here is 32. The largest x value here is 89. Do you see 72 lies between 32 and 89? If it lies within the given data, it is interpolation. And what do you know about interpolation? Interpolation will be a strong correlation. It will be an accurate value that you determine by substituting the x value into the regression line. That is interpolation, because 72 lies within the data range, and that will give you an accurate value. Interpolation is accurate. As soon as you take a data value of x, which lies outside the range, for example, I am going to use 102. Right, if I use 102, do you see? If I look in terms of the x value, 102 does not lie between the smallest and the biggest x value. It is called extrapolation. Extrapolation. And extrapolation does not give you an accurate answer. Is that clear? It is not going to give you it's not going to be an accurate value. All right, is that clear? So know the difference. What is interpolation? It lies within the data set. Extrapolation, outside the data set. Interpolation gives you an accurate answer. Extrapolation does not. Not accurate. You need to know that. Right. Next. They say in 1.5. Right. People, here we are on 1.5. Using the scatter plot and the table, using the scatter plot and the table above provide a reason why IQ is not a good indication of the number of votes that the learner could receive. Now, people, do you see this here is a scatter plot? It is all over the place. This scatter plot does not relate to this data set. You see that? If I have to plot those points, you can see it's 32.9. Here it starts with 98 to 123. This is not a scatter plot of this data set. They're asking a question that says, there is IQ, there's a number of votes. If the dots are all over, if the dots are scattered, if the points are scattered, then it's going to be a weak correlation. If you draw a regression line and the points are around the regression line, then you will say that it's a strong correlation. Is that clear? Are you happy with that? Okay. So what do you know about IQ? It's not a good indicator. People, there's a weak correlation between the number of votes and IQ. Why? Because the points are scattered all over the place. If the points are very close to each other like this, and you draw a regression line, then it's a strong correlation. Is that clear? But the first one is a weak correlation. The next one, the prediction in question 1.4, is it reliable? Now, people, if they use the word reliable, they want the correlation coefficient, correct? They want to see, is there a strong correlation or a weak correlation? So this question of 1.5 is not related to the table. Now they're asking you something that is related to the table. So now we've got to work out the correlation coefficient there, the R value. Right, now if you work out the R value of that, then we can go to AC, shift, stat. Okay, now because I went to AC, I've lost all my data. So I will redo the data. So here we're going to go to stat. We're going to go to 2, and we're going to redo it. I want you to work out the correlation coefficient on your calculators for this data set. Please do that now. Right. So people, in this case, your correlation coefficient will be 0.98. So if your correlation coefficient is 0.98, then it is, you name the correlation. Is it positive or negative? If it is close to 1 or -1, it is strong. If it lies between 0.5, it's moderate. If it lies closer to 0, it's weak. So in this case, people, we can see it's a positive value. So it is positive. It's close to 1, so it's a positive, strong correlation. Is that clear? Between the number of votes, in this case, and the popularity score. Is that clear? Right. People, I'm going to leave out question 2. I'm going to go to question 1. Let's go to question 1. I just want to cover all the possible questions that could be asked. We can go back to question 2, but let's go to question 1, where the scatter plot is drawn. Right. Right, people, let's quickly have a look at the following. They say a mathematics teacher was curious to establish if her learners' mathematics marks influenced their physical science marks. In the table below, the mathematics and physical science marks of 15 learners in a class were given as percentages. Mathematics, the first learner got 26% for mathematics and 34% for science. The second learner got 62% for mathematics and 67% for science. Right, etc. Now they say, determine the equation of the least squares regression line of the data. Now people, you've got to work out the values of A and B for the data set. I want you to do that quickly on your calculators. Work out the values of A and B of the regression line. Right, people, the value of A is 9,5. The value of B is 0,91. Did you get that? Right. If you are battling with your calculator and you cannot get the values of A and B, I will help you after the class with that. Right, the next one, people, they say draw the least squares regression line. That is why I focused on this question, because they're asking you to draw the least squares regression line. Now people, look here. Here you can say y is equal to 9,5 plus 0,91x. You see, that is a straight line equation. Y equal to mx plus c. So your c value is 9,5, which means your y-intercept is 9,5, correct? So if you have to sketch this regression line, you will see 9,5. I make that big dot there. That is your y-intercept. Now people, I'm going to use the method of the mean point. What is the mean point? The mean point is the average of the x values. So I'm going to add all those x values divided by 15. The average of the x value is 45,1. I'm going to find the average of the y values. So I'm going to add all those values together divided by 15, and the average of the y values is equal to 50,5. Is that clear? So that's my mean point. I'm going to use my mean point and my y-intercept to draw the least squares regression line. So if your x value is 45,1, right, your x value is 45,1 and 50,5. Do you see? It's that point there. And I'm going to make a straight line going through those points. Now people, take note. When you draw the least squares regression line, be careful for this, because you can throw away unnecessary marks. This here is a dotted line. A least squares regression line must not go past the smallest x value and the largest x value. Only that part must be shown on the least squares regression line. Is that clear? You can draw dotted lines here to show that I am using my y-intercept and my mean point to draw the least squares regression line. But when you draw the least squares regression line, it cannot go past the smallest x value and the largest x value. Only that part must be shown. If you're going to go over that, they will subtract marks. Is that clear? So that is very important. Okay. Now you have found the equation of the least squares regression line. You have drawn it. How do you do it? The y-intercept and the average of the x and the average of the y, the mean point, and a straight line through it. And don't go over the smallest x value and the largest x value in the table. Right. Next. They say, predict the physical science mark of a learner who achieved 69% for maths. So people, maths is an x value, correct? The first row is x, your second row is y. Is that clear? Your first row is x, your second row is y. Now you're going to substitute 69 in place of x in the least squares regression line. And you're going to get 72,29%. So predict the physical science mark. Y is a physical science mark. By substituting 69 into the least squares regression line, I get a value, a y value, and y represents the physical science mark of 72,29%. Is that clear? Now people, let's just quickly look at 69. Is that an accurate mark for science? Is it interpolation or extrapolation? Interpolation. Do you see that x is 69? 69, the smallest value here is 19. The largest value here is 76. Now 85. So it lies between 19 and 85. 69 lies between the smallest and the largest value. So it's interpolation, which means the answer you get for your physical science mark is accurate, is relatively accurate, because it's interpolation. Is that clear? Have you got it? Right, next. I want you to go and work out the correlation coefficient. There's the answer. I want you to go and do it now on the calculator. Right, I'm going to give you a few minutes to do that, to work out the correlation coefficient. And see whether you get that answer. Right, people, once again, while you are working out the correlation coefficient, what are you going to get when it comes to statistics? The box and the whisker and the ogive, grade 11 work. And grade 12, the regression line. Right, is that clear? If you focus on those three, and you must also focus on outliers. What is an outlier? It is Q1 minus 1,5 times the interquartile range, and it is Q3 plus 1,5 times the interquartile range. Any values outside that is an outlier. Is that clear? So that is the terminology that I did not use last week, but you need to know what is an outlier. And if you look at the scatter plot, an outlier is a point that lies far from the least squares regression line. It is something very odd. It doesn't lie close to the regression line. It's a point very far from the regression line. So that is how you can identify an outlier from a scatter plot. And in terms of data, we use the two formulas, Q1 minus 1,5 times the interquartile range and Q3 plus 1,5 times the interquartile range. And the value that you get will be anything greater than that or smaller than Q1 minus 1,5 times the interquartile range. Those are the outliers. Anything outside that interval. Is that clear? Okay. People, did you get R is equal to 0.95? Right, the next question. Comment on the strength of the correlation between mathematics and physical science. Now I said, when you comment on the correlation, you first comment, is it positive or negative correlation? A positive correlation means if you draw a least squares regression line, it's going to be a positive gradient. If it is a negative correlation, the gradient of the line of the least squares regression line will be negative. Is that clear? So let's quickly have a look. Is it positive or negative? It's positive 0.95. Is it close to 1? Yes, it is close to 1. So it's strong. It's a positive, strong correlation. Is that clear? If there was a negative 0.95, it's a negative strong correlation. If it's 0.5, around about 0.5, it's moderate. If it's close to 0, it's weak. Is that clear? So know how to interpret the correlation coefficient value. Next. What trend did the teacher observe between the results of the two subjects? People, there's a strong correlation. A high mathematics mark is a high science mark. A low mathematics mark is a low science mark. Is that clear? Okay. Right. People, now we can go back to question 2. Right. After this, people, you will see that you will be able to answer any question. This is a repetition of what we've done, but I want you to do it now. They say, in this case, a farm store sells milk in 5-liter containers to the local community. The price varies according to the availability of milk at the farm store. The price of milk in rands per 5-liter container and the number of 5-liter containers of milk sold are recorded in the table below. On the grid in the answer book, draw a scatter plot to represent the data. Now, people, then we've covered every type of question. Let's quickly have a look. Right, I need your attention on this one. We are going to draw a scatter plot. Are you with me? Okay. Now, people, they even marked it for you. Your first row is X. Your second row is Y. Or your first column is X. Your second column is Y. Follow the rule. Yeah, you got to plot the point. X is 26, Y is 48. X is 26, Y is 48. Gives me that point there. Correct. Right. The next one, 32, 30. X is 32, Y is 30. X is 32, Y is 30. That gives me that point there. Right. And then we can plot each of them. Remember, if 3 to 5 points are plotted correctly, you will get 1 mark. So you've got to be accurate. You always need to determine the scale. So here you can say there's 1, 2, 3, 4, 5. So every block here, every line there represents 1 unit. And here it goes from 20 to 25. Every block there, or every line represents 1 unit. So always look at the scale in order to determine whether it is in 1s or 2s before you plot your point. Is that clear? Look at the scale. Right. So people, if you get 2 marks, if 6 to 9 points are placed correctly, and if all the points are plotted correctly, you will get 3 marks. You understand the scatter plot now? Okay. Now they ask you, in this question here, they say, determine the equation of the least squares regression line for the data. Now, people, I want you to go, the answer is there, go and work out the values of A and B. Do you want me to do it with you, or are you okay? Are you okay? Right. I want you to quickly work out the values of A and B. People, you'll walk out of this class, and at least this is a section that you can get quite a few marks for. Right, quickly go work out the values of A and B on your calculator. Right, people, did you get 90,48 for the value of A? And did you get 1,77 for the value of B? Great. People, yeah, we can say in 2.3, if the farmer sells a 5-liter container of milk for 38 Rand, predict the number of 5-liter containers of milk he will sell. Now, do you see 38 Rand is the price. So that's an x value. So by putting the x value of 38 into the least squares regression line, I will get the number of containers of milk, and it's 23,22 units. Is that clear? Right. And then people, I want you to work out the correlation coefficient in 2.4. They say, refer to the correlation between the price of a 5-liter container of milk and the number of 5-liter containers of milk sold, and comment on the accuracy of your answer. Right. I want you to go work out the correlation coefficient R. I said what you must be able to do on your calculator is to work out the mean of discrete data, the average or mean of discrete data, the average or mean of group data, the standard deviation on your calculator, the values of A, B, and R on your calculator, and you've got 8 marks out of 20. As easy as that. Right, people, there's your 3 marks for A and B. Here's your 2 marks. And by putting the x value in there, you've got 7 marks. Is that clear? That is without anything else. So the questions out of 10, you shouldn't be walking away with less than 7 to 8 marks out of 10. Right. Who's still busy with correlation coefficient? You finish. Right, okay, people. The answer is negative 0.94. Now, people, let's explain negative 0.94. Negative sign says a negative correlation. And it's close to -1, so it's a negative strong correlation, correct? And how will the scatter plot look like for a negative? If you draw your regression line, you see, people, if you draw your regression line, it will be a negative gradient. And a negative gradient is indicative of a negative correlation. A positive gradient is indicative of a positive correlation. You understand where the two link? Right. Are you happy with that? Okay. Great. People, that brings us to the end of this question. I'm just going to quickly go through the probability of last week. I'm going to go through a little bit more difficult questions with you. Are you happy with that? Right. Right, people, let's quickly have a look at this question. Question 4A, it's in your notes of last week. They say, how many different codes can be generated if the following principles apply? Codes may consist of 5 characters, namely 2 letters and 3 numbers. Letters may be repeated, but not numbers. And the number 0 may not be used. Right, now people, look here. How many codes can I generate? Now, there are 26 letters in the alphabet. So, and it's 2 letters. So here we can say it is 26 for the first letter, and it can be repeated, so we can say there's 26 letters for the second one. Is that clear? Right. The numbers may not be repeated. If I take away the number 0, then I'm left with 1 to 9. So there's 9 numbers that I can place in the first position. And numbers cannot be repeated. So there's any 8 numbers can take the second position. And then 7 numbers can take the third position. So the total number of options is 340,704. Right, is that clear? Right. Okay. Now the second part, people, take note. It says, If the above mentioned principles apply, what is the above mentioned principles? There is 5 positions. 2 of them are letters, 3 of them are numbers, and the letters can repeat, but the numbers may not. Those are the principles. They say, determine the probability that the code will start with a K and end with an even number. Now people, how many letters can I put to the first block? Only K. I can only put 1 letter in the first block, correct? Now people, letters may be repeated. So in the second block, I can put any of the 26 letters of the alphabet, correct? And then, they say to you, the last digit must be an even number. So in the last digit, I can either put a 2, 4, 6, or 8, correct? I can put any of the 4 numbers, 2, 4, 6, 8, in the last block. So I've already used a number, correct? So how many numbers can I put in that block there? Out of the 9 numbers, I've used an even number for the last one. So yeah, I have got 8 numbers left. Numbers may not be repeated, so I've got 7 numbers. So if I multiply 1 by 26 by 8 by 7 by 4, I get 5,824, correct? They say, what is the probability? Probability is the event over the total number. The event is 5,824 over the total number with no restrictions, which is 340,704, gives me a probability. Probability lies between 0 and 1, gives me a probability of 0,017. Correct. Are you happy with that? Are you okay? Right. Let's go on to some of the more difficult questions. There's one more question that I want to do with you. Right. In this case, yeah. Right, people, given the numbers, I'm going to do this one here, number 1.1. In actual fact, I think we need to do it together. I'm going to read the question, you do it, and I will answer it. Is that clear? Right. People, they say, given the numbers 1 up to 9, how many 2-digit numbers can be formed using the numbers above? Numbers may be used repeatedly. 2-digit numbers. How many numbers are there? 9. So if it's a 2-digit, in the first block, I can put 9. In the second block, again 9. Correct. So for 1.1, it's 9 times 9. Correct. I said you must do it, and then I've already done it. Okay. I want you to do 1.2. I'm going to read the question, and I'm going to give you an opportunity to do it. 1.2. How many 4-digit PIN codes can be formed using the numbers above? Numbers may only be used once. It's a 4-digit PIN code. Right, I want you to try and figure that one out. We are busy with 1.2. Right, people, if some of you are a little bit quicker, you can do 1.2, then move on to 1.3. I just want to do up to 1.5 with you. So if you're quick, you can continue with the others. I'm just going to give you another 30 seconds. Right. Okay. People, there is the 4-digit PIN code that I can use. I've got 9 numbers. The numbers may not be repeated. How many numbers can I put in the first block? 9. They may not be repeated. How many numbers are left? 8. How many numbers are left? How many numbers are left? So if I multiply that out, the answer is 3024. That is the number of codes I can generate. Is that clear? Right. People, we are now going to look at question 1.3. Go ahead and try and do question 1.3. People, it's a 4-digit PIN code. The first digit must be a 3. So how many numbers can I put there? 1. There we are. Let's quickly have a look at that. People, the numbers from 1 to 9. The first number must be a 3. So how many numbers can I put there in? 1 number. And they say in this case, the numbers may be used repeatedly. So if I put 3 there, how many can I put in the second block? They may be repeated. I can put 9. The third block and the fourth block. So if I multiply that out, I will be able to get a value of 729. Is that clear? Are you happy with that? Okay. All right, people, let's look at 1.4. Here they're saying, how many 4-digit codes can be possible if the code has to start with a 1 and end in a 9? Numbers may not be used more than once. Right, I want you to go and figure that one out quickly, please. You will draw your 4 blocks, 4 digits. In your first block, you can only put the number 1. So how many digits can I put there? 1. And it must end with a 9. So in the fourth block, how many digits can I only use? 1. They say the numbers may not be used more than once. So if I use 2 numbers, how many numbers are left? Right, you figure it out quickly, and then we can do the answer. Right, people, let's do it together quickly. Here we've got 9 numbers. The first block must be a 1. So how many numbers can I put in there? The last block I can only put in 9. So how many numbers can I put in there? Right, and then they say to me, the numbers may not be used more than once. So of the 9, I've used 2. How many are left? Right. And then, in this case, how many are left? Right. Is that clear? Right, people, let's go on to question 1.5. Right, question 1.5 says, how many 4-digit codes are possible if the code should start with should have at least 1 5 and the numbers may be repeated? Now, people, the emphasis on at least. Is that clear? Right, I want you to go ahead and do that. Right, people, let's quickly have a look here. This is the last one. Right, when they say at least, people, that means at least means 1 or more 5, correct? So if we look at the 4-digit codes must have at least 1 5. At least 1 means 1 or more 5 in the code. So what we're going to look is the total possible outcomes, correct? Yay, people, the numbers may be repeated. So if I say the total possible outcomes, that is not taking the restriction of 5 into consideration. Okay, how many numbers can I put in there? 9, 9, 9, 9, correct. And that gives me a total of 6561. Now, people, the total possible outcomes without a 5, no 5. So if I take 5 away, how many outcomes have I got? 8. And it may be repeated. This is without an 8. That's 4 without a 5. 4096. So 6561 minus 4096 equals 2465. That is the total number of outcomes with at least 1 5. Is that clear? Right, people? I really wish you good luck for Friday, paper 1, as well as for Monday, paper 2. And I'm sure, people, that you will do well. Put in the time, put in the effort, learn your proofs, and I'm sure that you will do well. Good luck for the exam.